find the volume of the solid obtained by rotating the region bounded by y equals x cubed and then we're going to do y equals 8 and x equals 0 about the y-axis. So I need, again, a picture of my region to start with if I'm going to figure out how to set up this integral. So we have these three equations here, y equals x cubed, y equals 8, x equals 0. If I find the intersection points of y equals x cubed and y equals 8, you're going to get x equals 2. So I'm ready to draw this graph now for you. Zero, 1, I get 1. But when I plug in 2 into y equals x cubed, I'm going to get 8 now. 8. So I get 8 here. Okay.
Yeah, it's supposed to be y equals 0, or is it x equals 0?
X equals 0.
Okay.
Mm-hmm. So then if I graph y equals 8, it's going to be this line here. And then x equals 0, that's the y-axis here. So my region that's bounded by all of these, that's this region right here. And they tell me in the problem that I'm rotating about the y-axis. So I want to take this region and I want to rotate it around the y-axis. So again, you're kind of going to get this bullet head filled in bowl shape going on. So now you always take your strips, they're going to be perpendicular to your rotation. So I don't want to have to draw a whole nother picture. So let me erase this blue stuff. I'm rotating about the y-axis. So now my strips are going to be taken like this. They're perpendicular to my rotation line. And you rotate that around, and you're going to get another disc when you rotate that around, just like last time. You're going to get another disc when you rotate that around. But now, remember I said the dx comes from how high, how tall your cylinder is? In this case, the height here, it changes in the y direction. So what that means is I'm going to need to integrate with respect to y. Okay? So if you see something where you're rotating about the y-axis, if you're using this disk method, then you need to integrate with respect to y. So then the formula that I was using before So let's say C to D. Now it's going to be AY dy. But I still have a disk, so my area formula is still going to be given by pi r squared. AY still given by pi r squared. And now we've got to figure out what our radius is for this disk. Well, the radius, if you look, I go out horizontally, which means that's an x distance. Here, x. But it depends on this function, y equals x cubed. So it looks like r is going to be x, but I need to incorporate my function, which was y equals x cubed, into that. So you're going to have to solve for x in this equation. If you solve for x in this equation, you're going to get y to the 1/3 power. And that is your r here. Okay, so r is going to be y to the 1/3. And then after you know your radius, you're ready to go on your integral. So the volume is going to be pi y to the 1/3 squared dy. And now I just need to figure out the bounds on this integral. Remember, my integral is in terms of y, so let's go back to our picture and look in terms of y. What value should I use here? 0 to 8. Exactly. Use 0 to 8. Okay. And then after you set up the integral, you just need to integrate. The difficulty really comes from setting these up, and after you set them up, it shouldn't be too difficult to integrate. This is y to the 2/3, and then do your reverse power rule where you add 1 to the power. So it looks like pi y to the 5/3 over 5/3. And you plug in 0 to 8 here. So I'm getting pi, flip your 5/3, so you get 3/5, 8 to the 5/3. And so I think this simplifies to 96 pi over 5. So when you're doing these methods, remember, it matters where you're rotating about. So in this problem, I was rotating about the y-axis. I have my y-axis here. Your strips are always perpendicular when you're using this method, so I draw my strips here. And then you're going to have to integrate in terms of y for this one. So it might help if I had fully drawn this as a rotation. You rotate it around.
So your radius, whenever you're doing it for y, is just whatever x equals, correct?
Is whenever you're rotating about y, it's equal to x.
And whenever you're rotating about x, it's equal to y.
Okay. As long as you're doing x-axis and y-axis, yes.
Okay.
At some point, we're going to rotate about a non-axis line, which is going to change that. Yeah, a lot.